Wait, we got to get some sound on. Wait, hang on. Hello, there you go. Okay. So it is Thursday, and we're going to be talking about more integrals and derivatives that involve ln. Eventually, we're going to get to integrals of tangents and cotangents. But let's take a look at... What was? Really? Oh, that, yeah. I was talking to Jay about that. How to figure out the number of digits in a base 10 number. Take the log of that number, log base 10, and add 1.
Why do you add 1?
Because it's off by 1. What's log base 10 of 100? 2. But there's 3 digits. It's off by 1. Okay. So, let's do stuff. Here we go. Come on. Okay, so consider the following definite integral. The integral from 0 to 2 of 2x over x squared minus 5 dx. This is new stuff.
I mean, like, you have to write this on a number. It's not this.
It's not that yet. Okay, well, like I said, everything got killed first period, so there's no notes yet. All right, so how would you do this definite integral? Or how would you get the antiderivative anyway? Any ideas? No, we don't really have a quotient rule for integrating. We're going to need ln here, yeah. So who's u? Well, hang on, it's a u sub. Who's u? Right, if u is x squared minus 5, then what's du? It's 2x dx. Okay. Well, guess what? We have 2x dx, don't we? So this is a straight u sub. So do you want to change the limits in u? Do you want to stay in u, or do you want to go back to x? What? What is he talking about? All right, look. Isn't this the integral of 1 over u du already? So do you want to change the limits of integration for u's, or do you want to go back to x's? Go back to x's? Okay, so what is it? The antiderivative of 1 over u du is? No. Were you here yesterday?
Yes.
The antiderivative of 1 over u du is? ln absolute u. But u is? X squared minus 5, okay. So you can go back to x, right? I'm doing the indefinite integral here. So let's use that. Let's plug that back into here. So that's going to equal the ln of the absolute value of x squared minus 5 from 0 to 2. So plug in 2, and what do you get? ln of what? 2 squared minus 5 is? Negative 1. Remember, this is an absolute value, right? Minus the ln of, plug in 0, what do you got? That's it. But the absolute value of 1, a negative 1 is? 1, so this is really ln of just plain 1 minus ln of just plain 5. But what's ln of 1? 0. So all you get is negative ln of 5. Okay? Some people like to write that this way, ln of 1/5. Is that the same thing? Yeah, because the ln of a quotient is the difference of the ln's. This is ln of 1/5 already. Or think of it this way. What number is in front of this ln? Negative 1. When do you get numbers in front of the ln? When it was an exponent. So 5 to the negative 1 is 1 over 5. So you can write this way, you can write this way. Okay? All right, we're getting a little too much noise over here. Go away. All right, so that's just a quick warm-up and review from yesterday. Let's take a look at today's packet. All right, we're on 88 BC2. Yeah, that's it. Unless you want a decimal, get your calculator out. You know. Okay, so take a look at 88 BC2. Let's see what we've got to do. 88 BC2. Okay, it says, let R be the shaded region between the graphs of y equals 3 over x and y equals 3x over x squared plus 1. And there's the graph. Now, which one is the upper function, the higher function? Is it 3 over x or 3x over x squared plus 1? The higher function is 3x over x squared plus 1? Not really, because what if you plug in 0?
No.
What if you plug in 0? 3 over x is undefined at x equals 0. And 3x over x squared plus 1 is 0 if you plug in 0, right? Which one looks like it goes through 0, 0? Which one goes through 0, 0 then? The bottom one, right? So the bottom one is y equals 3x over x squared plus 1. Now why do I care? Who's the upper function and who's the lower function?
Because you're doing area.
Volume or area, I'm trying to get the height of the rectangle, right? All right, so that's really part A. Let R be the shaded region, well, pretend it's shaded, between the graphs of y equals 3 over x and y equals 3x over x squared plus 1. For x equals 1 to rad 3 is shown in the figure above, find the area of R. Okay, so let's do that. Let's see, why don't we replicate this graph a little bit here? Oh, this one is the cool one? Oh, okay. According to Chris, that's not the cool one?
No, I just like change.
Okay. So here is 3x over x squared plus 1. Here is 3 over x, right? I want the area from x equals 1, let's say that's this, and x equals rad 3, let's say that's that. Okay? So this is x equals 1, and this is x equals rad 3. This is y equals 3 over x, and this is y equals 3x over x squared plus 1. So how are you going to get the area in here? Do you want vertical strips, horizontal strips? What do you want to do? Vertical strips would be easier. Horizontal is a pain because horizontal, the higher function is the one that's farther from the y-axis, would be this minus a constant. But is it always that? No, this messes things up. Yeah, that's complicated to do horizontal strips. So I'm going to stick with vertical strips. All right, so say I have a little vertical strip here. What's the thickness of the strip? Dx, okay. This thickness right here is dx. And what's the height function? What's the height of each rectangle, Riemann rectangle? This y, right, minus that y. Okay, so let's set up the integral. R is the integral from (1 to rad 3) of, okay, what's the height function then? 3 over x minus 3x over x squared plus 1. Again, we said that this was the lower function, right? And times the thickness of each rectangle, which was dx. That's why you got to write it. Okay, is this integrable? Yes, it is. No, it's not? Well, how do you integrate 1? Forget the 3 for a minute. 1 over x dx. How do you integrate that? That's ln. How do you integrate? You can forget the 3 also here. X over x squared plus 1. That's going to be ln also if you do a u-sub. Who's u? X squared plus 1. So who's du? 2x dx. So forget the 3 for a minute. I have an x dx. How do I replace x dx? With du over 2, right? All right, so this is equal to 3 ln absolute x minus 3 halves ln absolute x squared plus 1. Is that correct? Are we okay with that? Anyone disagree with that? I didn't write any u stuff. You could do that part in your head, can't you? Okay, so here's 1 and here's rad 3. So let's plug in stuff. So plug in rad 3. Well, now we get 3 ln rad 3. Okay. Minus 3 halves ln of, well, rad 3 squared? 3 plus 1?
Wait, isn't it? Yeah,
4, right. And the absolute value of 4 is just plain old 4. You don't really need the absolute value, do you? All right, so that's when you plug in rad 3. What else do you do?
1.
Plug in 1. Okay, so take this stuff minus plug in 1. All right, so it's 3 ln of 1. Again, the absolute value of 1 is 1. Minus 3 halves the ln of 2. Right? Again, 1 squared is 1 plus 1 is 2. Absolute value of 2 is plain old 2. I don't really need the absolute value there. And this drops out. Good. Now look, there's a 3/2 here, right? There's a 3/2 here. Yeah, but wait. This drops out. This is gone, right? There's a 3/2 here. There's a 3/2 here. Is there a 3/2 here? Actually, there is. Do you see it? What's the ln of rad 3? It's the ln of 3 to the 1/2. What do logs do to exponents? Bring them out front. Yeah. So how about we take out 3/2 everywhere? And we get 3/2 times ln 3 minus ln 4. Now this is 0, right? ln 1. Minus is plus ln 2. Now that's an answer, but it's not in simplest form because doesn't ln 4 have something to do with ln 2? These combine. Why? How?